Good morning. Welcome to day 86 of Project Dig. Thank you for joining. Project Dig is a 2D multiplayer automation survival sandbox game that I am developing here entirely on Twitch and uploading all the VODs to YouTube. We're making a custom C++ game engine, and we've been doing, entity component system and rendering and water simulation via cellular automata. And right now we're working on a particle system so we can have particles, yay, for stuff like when you hit a tree, we can have like wood chips fly out, or steam coming off of some I don't know, steamer thing machine, or smoke coming from torches, whatever. So that's what we'll be using particles for. They're used for so many things. And yeah, we started working on it last week. So we'll just be picking that back up. We don't have too much time today. I kind of forgot, and I was just reminded like 2 minutes ago that I need to be watching my daughter at 10:30. So yeah, we have about 1 hour, or just a little under an hour today. Hey, Chemist and Cooler, welcome. Yeah, it's been hard to find time to stream with just life. Newborns and toddlers take a lot of time. Let me tell you, they take a lot of time. Okay, so I'm not going to completely recap things, since we don't have much time today, and watch day 85. So what we're working on last is just trying to get the particles up and running. I fortunately did make some notes here. So one thing we need to do is get it so that our particles are actually moving according to the speed, gravity, the attractors, and repellers. As I said last time, let's just get the most basic thing working, and then we will try to do some rendering support for it. And then once we get like the basics of the rendering working, we can go back to the like simulation for the particles. Hey, Zenjitsu asks, from 1 to 10, how data oriented is your engine? I mean, I don't know exactly what a 10 is. It's definitely not a 10, but it's not a 1. I don't know, it's 5, 6. I'm trying to keep things data oriented. It doesn't always make sense to have things be data oriented, but the whole point of data oriented is to put data first. Think about the data and try to write the program to handle the data the best way possible. Sometimes you don't really know what the data is going to be until after you've already written the code and have things running and working, and then you're like, oh, actually, I'm using it for these other use cases. Hey, Dallas, welcome back to the Seeds. 2 months. Thank you for the support. I appreciate it. Thanks for joining regularly. It's nice to have a new regular person. Like, Cooler and J-Comis are both super regulars. Dallas, welcome to the team. Yeah, this for loop, and like the particles are actually really great for data oriented, because that's like the It's actually what a lot of people will write whenever they're writing particle systems. They will write it in a data-oriented approach, or more so than most things, because it kind of lends itself very easily to that. And you kind of have to think about it data-oriented, because if you don't, then you're not going to get very many particles. Yeah. So yeah, there's still something that we need to do with it, but this is trying to be as concise as possible. So yeah, we get the entity, the transform, the emitter. We just go through all the emitters. We're trying to update the positions for the particles. I think that's, let's see here, where do we, oh, here we go. Yeah, this is where we determine where it's going to be at. And then we also like to set up the particles. So this is where we are emitting the particles. And then down here is where we are updating them. This is where the particle has expired, and so we're just swapping it with the last particle. I should say with the last particle in use, because that's what we have here. So we're just trying to keep this list of particles densely packed. That's what we're trying to do. So that way we're not having to skip over any particles like, hey, is this particle an active particle or not? And we also know exactly what particles are. We just say, hey, everything from 0 to the channel state dot count, which is the number of particles active, are the particles that are active. And everything from the count to, it's actually count -1, I think. Yeah. And then everything from count to the size, the last particle, and the list are unused. So what we need to do here right now is try to just update the particle with some of this information. So we have the speed, the scale, the angle. Hey, Jeremy, speaking of the usual suspects, what's up, man? Is there a way to break the branches here by using more tables? Quite possibly, probably. Like, I don't know if it's worth it. Right now we're trying to do the most simple approach, but yeah, maybe like, I don't know about the lifespan. I'm sure there is a way to clean things up more. Yeah, there's a lot of branches. That's something that I would say I need to improve upon. Yeah, this right here. Yeah, the thing is that this is if the particle life has gone beyond the lifespan. So like, I don't know. That's definitely worth thinking about. I would say I would not worry about it right now, and I'd rather get some basic stuff working. And because we're still like figuring out exactly what this is going to be like, this code is going to change some. I would say typically you want to get the code like mostly completed, so that way you have a full understanding of what are all of the requirements, because you're always going to be forgetting about something, and then kind of go back and optimize and really think like, okay, now that we know all of the use cases that we're going to have in this code, let's or like the path flows, let's see if we can think about it differently. Yeah, maybe we can do something with the lifespan. I'm not sure. Like maybe you could have that be in a different its own list or something like that. It's like a vector, and then if that was sorted, then you would know like here's the particles that they're being updated or something. I don't know. Yeah, it might be possible to sort by time. I don't know if it would make sense to sort it all by time. But maybe whenever it gets added, I guess it would only have to be whenever we add a new thing, it would be added to the front. The thing is that it's a random. So I guess it's kind of dependent on the lifespan, right? Not how long it has lived for, but how long it's going to live. That's the thing that matters the most, right? No, I don't know. I guess maybe what would be easier is to say how much time. This is probably actually better. Is how much time it has left before it should expire, and maybe that would be the better way to go about doing that. The reason I have it in these two, like split up in from life and lifespan, is because we need to take a percentage of how much time it has remaining, such as we do here. But yeah, there are absolutely ways we can think about how to better organize the data to handle this. There's actually a lot of things we can do with the particles right now. Like, I haven't actually figured out exactly how we are wanting to set these up. Like right now, our emitter channel state, which goes into the emitter component, has all of the particles. So that means that every single component is creating these particles, but they really could be shared. So instead of like creating them, we could allocate them in one place and then kind of assign the particles to the emitter channel state. But yeah, haven't gotten into that yet. I think I've had too much coffee and buzz in here. Nice. I'm on my second cup today. Last night was a tough night. Um, and I only helped out a little bit. Can't imagine, Kelly. Babies. Okay, so yes, let's actually do this. I'm on my third thing. Yeah, well, I'm drinking double shots, so I can't drink more than like 2 cups, otherwise it's a little too much. Okay, so we're supposed to be moving it based off of the speed and the direction. We probably... Wonder if we should... I guess we should update the angle and the direction first. So what we actually need to do, and this might be a place where we could try to like optimize this as well. Oh, not the angle. Let's not worry about the angle. Direction and speed. So the direction right now is like 0 to 360. So we need to convert it to radians, and then we need to do cosine and sine to get the x and y velocity, and then we can apply that to the coordinates. Because we need to get you guys some help on 3 cups of coffee this early. Yeah. Okay. So I don't know if C++ has anything on degrees to radians, or if we just need our own little function. We want the inverse. You're doing it backwards. That's the arctan, right? I have this actually implemented in Korea. I don't remember where. I think we do have it in vec.hpp, right? Okay, angle, radians 2 degrees. So it's just this const. This is radians 2 degrees. So wait. Ah. I have a like degrees to radians as well, right? I had a DV upgrade this morning. Ew. Sounds like fun. So I think we have a degrees to radians, maybe somewhere. Yeah, there we go. So we can just use these two. So we should probably go to math dot. Wait, why do I have a math util? Oh, that's for spine. I bet they even have something like this, huh? Pi degrees to radians. Yep. Math util. Yeah, I don't really want to use the spine stuff. Let's go ahead and put it in here. So we do have a... Where is that at? I'm pretty sure I used MPy elsewhere. Maybe? Maybe not. I guess it's defined somewhere. STL2. Oh, whoops. I actually want to put it in the header. And we need to go the other way as well, which we can just grab here. I wonder if I should condense this down, like degree to rad. And rad to... I guess I should probably be consistent here, right? Okay, so... Oh, I have this inside of projectDIG. Oh, whoops. Okay. I didn't even realize I did that. I guess I need to now include... That's probably where the C math is coming from, huh? Maybe what we'll do is this. Include siege. Hey, Mind Rage, what's up? Siege utility math. Okay. So now that we've done that, what we want to do is to get the speed of a particle. I am working on particle rendering, well, getting particles moving a little bit, and then we'll try to do some rendering. But unfortunately, I was reminded that I don't have a lot of time this morning, so it's going to be a very short stream. We probably won't get too far. Yeah, since we had the in-laws visiting the first like few weeks after Emmy was born, and they were helping a lot, and they left like a little over a week ago, and we're definitely feeling their absence, where it's like, okay, gotta take care of the girls all the days. um yeah, so consequently, finding time to stream has been challenging, to say the least. Okay, so move the particle. So speed is just a multiplier. So what we need to do is take the direction, convert the direction into radians. So this is like the direction, radians, direction, I don't know, whatever. So that's going to just be the particle dot direction times, we want the degrees to radians. So how's the automata doing? It's good. It's fine. I actually need to do a recap video. I kind of meant to do one today. I don't know. I need to figure out my life. But it's good. It got to a good place. And so then what we need to now do is update the particle position, which is going to be the radians direction, and we need to then multiply that by, I always forget if it's the sine or the cosine. I think it's the cosine. SD cosine. And then we need to multiply that by the speed. So basically, this is giving us the, like, you know, it's on a unit circle, and so we need to convert it. So we're like, which direction is it moving in the x-axis? And then, so that's kind of like a unit circle, and then we have the length of the vector, right? Which is speed. I think that makes sense. Whoops. So one of these is cosine and one of them is sine. I think this is right, but I might be wrong. And so that's to move it according to the speed and direction. So, let me open up Korea. I've done this like many times. Here, no, not here. Oh, yeah. Hey, I got it right. See, so yeah, x is cosine, y is sine. Okay, cool. There must be a good way to remember that. But like maybe x and cosine, x and c are before y and s or something. I don't know. Okay, so this is actually going to be moving it according to the direction and the speed, which is great. I think we can now get to trying to render things. Time management is hard. AF, yeah. It's particularly challenging whenever you are kind of held captive by your children, and at any moment they might need you. And so it's like, can I do something now? How about now? No? Now? Oh, hey, I have 15 minutes. Let's do something. So yeah, it's just different from what I'm used to. I actually got bet. I think it's just something that you kind of like. Uh, you adjust, and I'm still in the adjustment period. Like with Kaylee, I adjusted, and I did fairly well actually after Kaylee was born. Although I will say it was a little easier because my wife was taking care of Kaylee a lot more. Um, Jason is held hostage. This is my cry for help, guys. Save me. Um, okay, so we need to add in the render, right? Right? Yes. Um, let's do that. Okay, here's the physics debug draw. So draw physics debug. Wait, I'm trying to think. Do I actually? Physics tile. I'm trying to think if there's any place in here that I do a good job with this. I guess what I could no. Okay, I think I know where I can look that up. So I'm trying to figure out exactly where I should be putting this draw information. I think I'd prefer to put it inside of other particle files. Particle. So I have the system and I have this other stuff. I don't know if this is actually a good way to go about doing this. So this is not in a namespace, but I was thinking maybe it doesn't make sense to put it in here. I think it might be okay. Particle. And so then this will have that draw function. I think I actually can just paste that. And that's where I need to add in a new file, which is the CPP for this. Add new item. Particle. That goes into source siege. That sounds right. Okay. And then we'll include particle.h, which is not the system one. Namespace siege particle. Actually, probably. Draw. Okay, so that can be our draw function. Whoops. So now we need to include the world. I don't know if we need HPP or not. And then the render system. So now that we have that, let's look up inside of game where we get the render. Wait, what it's called? What is it called? Render layers. So we need to do this. Yes, inside of here, I think it's probably okay. Actually, we might not want to put it in there. That's the update all. Yeah, I'm not completely sure where we want to put the rendering of things yet. Because it has to write to the render layers. It actually wouldn't be here. It'd be inside of the update. But all that really needs to do is write to it. Like, I don't know if it makes sense. I don't know. Maybe I need to change the design for this to some degree. But right now, we need something kind of like particle draw. And we want our particles to be maybe like 70 or something. I don't know. We'll figure that out. So then we need to throw into here our system particle. But we also need to add in particle here. So there's two particle header files that we are using. And then another thing we need to do is update our particle. Well, we actually need to do multiple things here. We need to add in the particle creator as well as the particle system. So here's our particle creator. Really need to come up with a better solution for this. Oops. Particle system. I think like a one-line thing. Oh, just, yeah, I think I said this before where I could say like schedule, whoops, something like that. Except for spelling that right. And that this would do this. Yeah. Anyways, I'll do that maybe next stream. Some point. Okay, so we haven't done the destroyer yet. That's fine. So with this, we made it so that our particle system is now actually running. And hey, Sound of Gaming, what's up? I'll be running, and we are trying to draw something. So that's great. Though the one thing missing is that we actually need to add in particles. So right now, our draw function doesn't actually do anything. Yes. What is this? Or where's that? I know somewhere I did pi. Where is that at? I'm trying to think where I put that. Pi. I remember I had to include. That's not it. Got a hundo on my first programming test. Nice. Congrats. Pi. Let's see here. Where's pi defined in the standard? Cd math pi. Use math defines. Okay, so I did that somewhere. That's the wrong place. I swear I did this somewhere. Just the other day. Nope. I guess not. But I believe that should fix it. Nope. Oh, maybe I have to say that it's in std pi. I don't know. That's cool. One moment, guys. I'll be right back. Okay, sorry. Does the project run or do anything? Yes. It will in a moment. I'll show you soon. I like this. I don't know why they even have to have it be a function. Oh, maybe if atan. No, atan has to be const expression, right? I don't know. Why can't I? Why is this not working? That's what I was looking at. See math. Why am I not seeing that? Okay, this maybe this is the wrong. I see. I was using the wrong header. There we go. That makes more sense. All right, so we'll just for declare these class world class render system should be fine. Uh-oh. We do have this was something that I wasn't too sure about. Maybe I do need to collapse this down. I guess so. Okay, we'll do it this way. We're going to do what I did in other places because it doesn't like me having two particle header files, which is understandable. So what we'll do is, whoops, let's get rid of that. For declare. We do need a few things up in here now, I guess. I don't think we need the array. We have vector. Types color. Okay. So yeah, we'll just collapse it down to a single file. That's fine. Should be fine. And then I'll delete those. Yeah, I'll have the game up and running here, hopefully in just a minute. Okay, so we'll delete this. We only want the system particle stuff now. So then we'll also delete the particle here, which means that, wait, cancel, let's save. We're gonna delete that. Which means that we need to make sure that we update any other place that includes system, or not system, just particle. So this. Oh, that's right. I guess that's fine. System. This is one thing that kind of sucks about this. Maybe I need to move it. And then this one we can just outright delete. Noita is coming out on the 21st. Yeah, I saw that. That's awesome. Looks very cool. I am, well, the tech looks very cool. I am a little skeptical, to be honest, of the game. Like, hopefully I'm wrong here, because they've obviously spent a lot of time developing the game. But from what I've watched so far, most of the game is like, oh yeah, this is a really cool sandbox game where you can, oh, I guess I do need the array. Include array. It's a very cool sandbox game where every single pixel is simulated, but is the game actually going to be fun long term? Like, or is it just going to be gimmicky? I don't know. They haven't shown too much, but and they did a talk about this, is like the whole trying to come up with game design that was fun in this like sandbox universe. Maybe they actually struck something that is really good. Noita. Yeah, I'll pull up this Steam page for it and share. Maybe they hit something good. I don't know. Hopefully. I know they said like they went through a lot of iterations, but, and I have done this myself, just because you go through iterations and when you finally hit something that you develop doesn't actually mean that it's good. Hopefully I'm wrong. But like sometimes it's just like the direction that you start with just like isn't actually fun. Like, and I think they had a challenge with this, is like, how do you make a game where everything is like crazy, random? How do you make that fun? Maybe they did a good job. I hope so, because it looks really cool. But I have also kind of gotten the impression from watching it that it looks like maybe it's just like all it is the gimmick, and there's not actually much substance. Well, that's because they've only shown it. I don't know how much there is beyond the whole like, oh yeah, every single pixel simulated. But like, how about other gameplay systems? Like, that's what's going to actually make the game fun long term. If all they have is a sandbox where you can run around shooting things and they explode, that will be fun for a while. But after, an hour or two, you're going to be like, okay, yeah, I've exploded like 20 different barrels and I've watched these guys slowly, burn to death a dozen times. Like I've seen everything. Like it's being simulated, but it's just like the same scenarios of things exploding and burning and eroding or whatever. And I could see that being fun for a short amount of time, but then after few hours, it would just be kind of old and not super interesting. So I don't know. We'll see. I think that's one of the challenges, and this is something that I have found with Korea, is that most games rely upon conflict, fighting with monsters or whatever, or fighting with the other players for like the majority of the gameplay. And whenever you have, especially sandbox games, 2D sandbox games in particular, their combat can be very challenging, and the more like involved you have the combat, I think the harder it actually becomes. And so then you end up with like combat that is like involved like Korea, but like it kind of goes against the actual sandbox where like the world is randomly generated, and so the terrain is not good to be fighting on, and so you're like, hey, I have this really complex combat system, but it actually goes against what the world is trying to do, and then you end up with like this not so great combat. And then it's like, well, if you don't have good combat with good controls, then what is it that the game is actually like kind of relying upon to carry it for for long-term play? I don't know. Like I was saying, hopefully they figured it out. Maybe the combat is really fun. So far what I've seen, it's just like shooting things and having stuff explode. But I don't know. I think it's probably going to be one of those things where it's either really awesome, like they just did a perfect job on it, or it's going to kind of fall flat. I'm sure there's going to be a lot of hype around it from the start because it does look awesome and promise not the developers themselves but the game concept. It sparks a lot of imagination, so kind of like um definition. Oh, am I pulling that in? F.H. Why is that being pulled in twice? Oh, I see. SDL include, I see. So maybe I don't want to do this then. I guess we'll try. Yeah. I forgot what I was saying. I hope they did a good job. Because if they did, then it's gonna be an awesome game. Okay, so apparently I do need that. Maybe it's because this SDL gonna include needs to be added in. Wonder what it would take for a game like Noita to be networked. Yeah, well, the challenge, and I was actually talking about this just the other day. Okay, let's go ahead and break. Come on. The challenge, I think, with networking the particles and everything is that you'd have to have it be deterministic, and you have scenarios where it's like, you shoot something and it catches on fire and there's flame particles, and maybe those flame particles might go over and catch this barrel of oil on fire, and then that explodes. But like, you have to make sure that that's all synced up, so that way you actually see something like that happening. Yeah, and like you said, determinism, right? So it's really challenging. You'd have to have it be very deterministic and be syncing, um, all of that stuff. Maybe like looking at what it'd probably be similar to what you do with getting physics to be deterministic through clients. So you could look at like what's his name? Getting Gaffer on games. He has some stuff on that. Gaffer on games. Gaffer, I think that's it. By the way, I only have like 5 minutes left or so before I need to call it. Sorry, short stream, like I said. Yeah, it would be very hard, which is why they haven't done multiplayer. And I'm sure as soon as the game launches, everyone's going to be clamoring for multiplayer, and it's just like, if they didn't plan for multiplayer from the get-go, it's going to be very challenging, I imagine, to retroactively add in multiplayer for that. How do you get that to build from Lime? From Lime? I don't know what you mean from Lime. Hi, Polymark. Welcome. Yeah, I was talking about doing stuff like that for the particles in... What's up with the compile time? Oh, you know, just, sucks. I'm gonna work on it soon. This is Visual Studio 2019. Yeah. Also, my computer's pretty old. We're going to be building a new one before too long. Oh, Sublime. Oh, I'm not using Sublime text for this right now. I actually don't compile with Sublime text. I always compile with VS 2019. Yeah, this compile time's pretty bad. Mostly due to templates, I think. It's also having to do all the Lua binding, which takes a bit of time. I cannot get Sublime to build with SDL2. Yeah, like I said, I don't build with Sublime, so I don't really know all that's needed. Like, are you using Visual Studio or MSVC for compiling, or like I've never even tried to set that up. I like using Visual Studio because of the debugger. Hey, look, we actually got it to build. The debugger, and then also I use Visual Assist for IntelliSense, which is pretty good. Okay, so yeah, we actually got the game loading here. So I think, yeah, we have our water simulation. This is our lighting, so we can change these blocks, so we can see, like right now it's doing this like kind of flood fill to figure out what we can actually see in the world. So if I break that open, we can see everything. We have our water simulation happening here. Yeah, I'm coding. This is Visual Studio 2019. I do use that's the wrong one. I do use Sublime Text, but I don't build with it. Whoa, it has UI and everything. Yes. Yeah, we do have a UI. We worked on that. If you go to the YouTube channel, you can see all of the videos I have done for this so far. So yeah, we do have UI, and it does do some stuff, and we can like type in things, and we have the whole entity component system and lots of stuff. We're on day 86, so we have done a good amount of development so far. So yeah, right now we're working on particles, and I was just trying to get like things to actually compile. Is the scheduler fully functional? No. It's extremely simple right now. All it does is we tell it what systems we're going to be using. I guess I should go to scheduler.hpp. So we say, hey, we're going to be writing or reading these components. We don't actually have a job system, you know, with bunch of a job pool that we're like having these various jobs multi-threaded running, doing things. That's going to happen in the future. Yeah, still lots of stuff to work on, but anyways, so man, I really wanted to get the rendering started, but did you get around memory management yet? Like, I've done some memory management, but not a ton. Like, we haven't built our own allocator or anything like that yet. Yeah, so we'll probably be kind of getting into that stuff in a while. Like, it's something I probably should have honestly done already, but I haven't. Like, I have been doing some things with the whole, like, you know, entity component system where we have a huge pool of components that we allocate at world construction, which is right now at launch, and we're just using those components, so we're not like allocating. So we're kind of have like, you know, a pool allocator kind of, yeah, I don't know. I haven't done stuff with that very much, so I'm still absolutely a novice in that regard. But anyways, so yeah, we have these particles, or not particles, water system, and we need to work on rendering particles, but unfortunately, I don't think I'm gonna have time to do that today. I need to get going here in just a minute. Yeah, sorry guys. I'm such a tease. All I really did was get it to compile and add that in. Yeah. So next time, we'll work on actually getting the particles to render and try to get more stuff done. So yeah, we'll fill out this function here, rendering the particles, and we'll start with something very basic and then extend onto, you know, doing more things. And yeah, we'll keep poking away at this. Thank you guys for joining. I really do appreciate it. Sorry that this was such a short stream. I do try to do more than just 1 hour streams, but life is keeping me busy right now. So I will try to be back tomorrow. I don't know exactly if that's going to happen. Wednesday should be a definite yes, since I have a sitter coming in the morning on Wednesday. So yeah, thanks for joining. If you enjoyed the stream, feel free to follow. You can be notified whenever I do go live next. If you haven't subscribed to the YouTube channel, you should do that. And so you can be able to catch up on videos there. And I will see you guys hopefully tomorrow. Have a good one. Take care.